Hey, hi everybody. So, so for today, we got this talk about how to handle 1 million events per second. I know why you're here. You want to find the answer to this particular question. I'm just thought of what would be the nice catchphrase that all of you guys would like to visit, and that's one of the thought that just appeared in my head. Just wow, I have to put some huge number there. 1 million events per second. That's why you're here. Okay. So just a couple things about who am I. I just got the same outfit, so you can recognize me. And my position at the Global Logic is to a big data architect. And what I do at the projects, I'm enabling big data. So if you have to start projects or you have already ongoing project and something going wrong with your big data, that's my job to get the order and everything in place. Okay, so let's go. How to handle 1 million events per second in Google Cloud. Use data flow, Google Data Flow, and you're gonna get these results. Any questions? Okay, I'm kidding. Yeah, of course. So before we even start, there are two types of persons. You can be both of them. You can't handle all. One of them, on the left side, is a software developer. Another one is a data engineer. Just raise your hand if this kind of words on the left, on the right side is the most closer to you. Who consider himself as a software developer? That's a back-end, front-end developer, so forth. Who consider themselves as a data engineer? Oh, okay, yeah, that's nice. That's actually true. You know, one of this. So in this area, I actually came from data engineering, data warehousing, and business intelligence. That was my background when I jumped into this. So when you have a big data project, that's very important to be on both sides of this. In most cases, people focusing on one side of the software development or data engineering. And most of the data warehousing and data lakes, they're actually missing a lot of things that are common for this type of people, that they know how to do this. Okay, so that was just a brief intro about the people, and we know who you are. Let's just quickly go through the agenda. I'm gonna show you how I jumped to this project. It was not from the very beginning from me. I was in the middle of this project. Then what we have started. Then how we changed our project, how this solution transformed, and then I would like to focus on some small things, but very important things, like non-functional requirements. When you start the project, you don't think about non-functional requirements very well, but they really affects your decision so hard you just can't imagine how they hardly do this. And I will briefly jump to the AI. Are we AI conference or not? So I will show you where is AI placed in this project. And at the end, I'm gonna make quick conclusions. Okay, where did we start? It was first of all very important to remember. It was a fixed price contract. So you have time frame, you have budget, do this. For the companies, such kind of, I don't know, like Global Logic, Luxoft, EPAM, it's not a common thing to work under this fixed price contract. But it was on this project. So where we have started. Customer asked, okay, guys, could you make cloud agnostic solution? I want to define my own rules. Just a quick, brief jump to the business area. Business area was security analysis. It was a lot of traffics going through the infrastructure of the customer, and they would like to define their own rules. How they could define some rules that could trigger on threats in their network. So we need complex event processing. We have to onboard a lot of data source types, like Cisco SA, Gigamon Flow, and so forth. There is a bunch of routers, computers, I don't know, devices in the network, up to 10,000. They really want in the very beginning ML and AI. Everyone wants ML and AI. They want quick analysis, quick search, and integration with their single sign-on. How do they would like to define rules? Simple example, if something bigger than value, for instance, bytes per second in the packet, that's an indicator high traffic. Kind of simple rule. Another one, a bit complex rule, they would like to detect port scanning. If you have connects to the different parts within some time frame, they would like to trigger this rule as oh, we got a port scanning. These two rules actually, they have quite a different nature. And this particular rule, and very similar to this one rule, we call them stateful rule. You probably do understand what does it mean, stateful. They share states. You have to aggregate somehow. This one actually creates a problem on the project. Another problem was, customer defines their requirement, but requirements was, I would say, very security specific. We've got business analysis on a project. It was a special guy who is an expert in security, but it still doesn't help us to build a good solution. We have no idea what customer means by CMDB, identity database, what all of these things. How we as developer can build something. Is it a huge amount of efforts or not so many? We don't know. So in the very first, it was this kind of architecture, this kind of diagram, and that was the very beginning and starting. I wouldn't say it's a bad solution or something was wrong, but it just doesn't work. It doesn't work. We tried to make as much IaaS in Google Cloud as possible. Okay, it was before me, not me, the project team. So it just doesn't work. What actually doesn't work? For the complex event processing, guys picked out-of-the-box tool, and it was Drools. I'm not sure, did you ever try this or not? You just can describe all these rules that I mentioned previously in a Java-like or English-like manner. And you can describe this. The problem is every processing of the rules, if you define a port scanning rule, and you have a huge amount of rows, everything goes to the single machine. So the single machine can't handle more than 1,000 rows per second. So we got a problem here. It was a first pick where to process all this data on a Spark server, and there is a special service at the Google Cloud, Dataproc. We tried this, but if you have to set up Dataproc in the very beginning, this cluster, and it's really hard to auto-scale this one. We have to manage our special connectors. We also have a monolithic backend. All the things just creates such a problem. Then I came to the project. Okay, yeah. Now what we have? First of all, we have to define our statement of work, SOW. First of all, I just take a look. What exactly defined at SOW? Take a look. If you see that something goes wrong with project, first of all, find out what your commitment on this project, on this solution. And what we decided, okay, cloud agnostic, get rid of this. We are fine with GCP. We do GCP, we okay with GCP services. Real-time event view, it wasn't a huge business value of this, get rid of this. Get rid of AI ML. Sorry guys, but if you want to establish a process, big data process, first of all, you have to establish core application. We're gonna talk about the core things further. Core thing actually was this rules engine, this CEP, how to create this one. So we have to get rid of AML implementation. We have to simplify how to measure performance of this solution. No sensitive data, just it really makes easier thing to do. And how did we transform our previous solution to the next one? From SKBAN, we moved to the Airflow. And for requirements, we have to start such kind of things like SRS. If you don't understand your requirements, create your own requirements. That's SRS. This is how you, as a developers, as architects, like as a delivery team, how you understand requirements. And you describe these things and map them to real requirements for the customer. That's really a huge boosting for your development. Now you can talk, now you can develop, now you can work with SRS. Very important thing for the big data. Just switch from any mutable things. If you do update something on the fly, get rid of this. Only immutable rows, only immutable, I don't know, events. Everything should be immutable. Don't do updates or other things like this. And we jump to another framework for the stream analysis. I really encourage you and recommend Apache Beam. Apache Beam, it's API and the framework. And it could execute it on top of any kind of resource managers. For this particular project, as we at the Google Cloud, we picked Dataflow. Dataflow was the executor of our Apache Beam defined jobs. That was a real core application. And NiFi was our ingest thing. Instead of maintain our own Java written containers, we started to use NiFi. Okay, that's how our architecture transforms to. We have in the very beginning our source ingest through the NiFi, hosted on virtual machines, then go through the Kafka. Usage of the Kafka just as a queue, nothing more, no Kafka streams, no Kafka as a storage, just as a queue. Then we do real-time stream processing. That's where Dataflow comes into the game. Then we have a couple of storages. We have to archive messages as is. We have to store them for the quick analysis. At the key value storage, that was Google Bigtable, columnar storage. And of course, secondary index as Elasticsearch. Our applications for UI was hosted on the OpenShift. And we also have a special database provided by customer to push our metrics. That was OpenTSDB. Okay, that's the same diagram, just describing the flow, what the main flow was, and how we utilize our main components. What kind of benefits we actually got from this, and what kind of challenges and problems we faced? First of all, this stateful processing problem. When we tried to pick a data flow, it was a lot of tools what to use. It was, okay, Spark, Dataflow, Flink. Which one to pick? How to make sure that that picked technology fit well in our pipeline, in our big data project. So where to share, where we have to store this state when we would like to detect this port scanning for 5 minutes. Should we pick some intermediate storage, or should we use workers and save everything there? So that's kind of questions that was we have to answer, and that pushes our decisions on the project. We even have a rule where we have stored 1 month of events. How can we do this? Can we store 1 month? What kind of size of data that's going to be with such kind of huge traffic? Yeah, and just for information, 1 million was a spike. Our normal flow was 250K per second, but it's still huge. So what kind of things? Customer also told, we want to understand what's going on your solution, on this system. So it was a question, what kind of metrics we would like to store, where them to store, which kind of level. Should we run something on a stream and count all these metrics? But the good question is, the good answer is for all of these things. Most of the technologies, Kafka, NiFi, Bigtable, they have out-of-the-box API to answer, to give you, provide you metrics. For instance, how many messages per second we have on the NiFi. There is an API on NiFi, just call this, save this. The same for the Kafka. We know how big is offsets. Okay, we know how they shifted. We have the answer. What's the performance of your Kafka? The same for the Bigtable. All of the things, most of the middleware metrics, you can easily collect from the applications. How to measure delay on your component? So, you know, there is a couple of components on your pipeline. Which one is the slowest one? How to detect this? So one of the answer was, OK, we just put a timestamp on every component, and then we can actually figure out what's the slowest one. OK, so when you can't actually work with every technology in your life. So what you have to do if you just face something new, do POC for everything. We have in the 1 year 200, we call them research spikes. We don't know how to work with Airflow. OK, create research spike for Airflow. We don't know how to work with data flow. OK, research spike for the data flow. And all of the things, if you don't know how to work with some of the technology, just take 1 week, 2 persons, assign to this one, and do research spike, and find out, does it work or not? Would work Elasticsearch for this kind of pressure? The answer actually is yes. So for all of the things, we have to create such kind of research spikes. For data flow, what kind of things we have to figure out? How does it scale? Is it auto-scalable? Can it handle 250K per second? And the answer actually yes. Do we have, for the storage, what kind of storage we have to use? Data store, nice service, but it can't handle such kind of huge pressure. It throttles throughput to the 300 messages per second, not K, 300 messages per second. So we figured out that data store doesn't fit well for our project. For the PubSub, would this work? What should we pick, PubSub or Kafka? PubSub actually losing messages. It doesn't guarantee a year ago. Now they actually implemented something for the at least one paradigm. But customer told, OK, we know how to manage Kafka. Let's stick with Kafka as a queue. For the Airflow, where should we go? There's a lot of options. Azkaban, Uzi, Airflow. What do we have? We have even service on the Google, Airflow hosted by Google. Composer. Which one should we pick of this? And Airflow actually a good one thing. Even if you do not use this as a cluster for computing, just for the scheduling. It's really nice to describe your pipeline and things in a Python manner. That works pretty well. But can this Airflow start stream jobs? Actually, yes. But can we do management of the stream jobs? Actually, no. But still, we didn't find any technology that could, out of the box, handle your stream jobs. For the bad jobs, yeah, Airflow is actually pretty good to start your job, stop your job, restart your job, and so forth. That's a nice one. For the NiFi, what we have to figure out, how NiFi would take care of your data if your upstream, downstream, Kafka is slowing down, throttling, or just going down at full scale. What NiFi should treat your messages. So yeah, actually back pressure and spilling works well at NiFi. Yeah, this one, it's not a technology, but the customer told, OK, guys, you have this archive storage. Can we repeat and just replay all this data that in your archive? And the answer was, yes, we can. How we supposed to do this? What kind of service you have to utilize? Actually, we create this replay service based on the data flow. Works pretty well. Okay, this one tricky thing. Customer ask us, okay, guys, what do you use on a Kafka commit? Is it an auto commit? And the answer was, yes, we have auto commit because it was out of the box. So the next question was, how you can actually guarantee at least one paradigm? Because Kafka responsible for your offsets, how Kafka does know that downstream successfully processed all the messages and didn't lose anything? What if your data flow just gonna blow up in the middle of the processing? What's your reaction? So we have to create a research spike and figure out how data flow can say Kafka and send the offset of the messages that were processed by the data flow. That's actually pretty interesting thing. We have opened a ticket at the Apache Beam project that has to help us to figure out how to do this. Because we have a feature at the Apache Beam paradigm and framework, but there is no good description how does it work. They just say, take it, it works. You have to believe us. Okay, yeah. So, yeah. That's kind of things that you're gonna face, I think, at every open source project. NFRs. Yeah, some NFRs that if you don't take them in the very beginning of the project and you just face them in the middle, they could hit you really hard. Well, such kind of NFRs was described like no message loss at every component, performance, of course, and secrets, how to store secrets, how to follow best practices, how to, your code has to pass every static code analysis. You have to encrypt all your connection from one component to another component. This is all the things, they kind of very important. Some of them we received from business. This kind of things, that's from business. Another part, very important thing, NFRs from DevOps. Just one of the things that I would say, be always friendly with your DevOps team. You're gonna receive a lot of useful things. They're gonna define, okay, guys, I want your services that you has written in Java to utilize console with service discovery. All the things, it's better to bring as early as possible. If you discover these gaps at the end of your project, that's gonna be just a disaster. So they told, okay, we want to that your applications, every component, follow circuit breaker paradigm. We have to embed histories and resilience for J very quick. That was really a surprise for us that DevOps bring this at the late game of the project. Every component, when it starts, it has to pass a health check. So it has to start independently. So if you have applications that depends on Elasticsearch, and you start this application, and there is no connection to Elasticsearch, your application has to say, okay, I'm fine, here is your signal, 200, I'm okay, my health is okay. But if I have dependency, this dependency has to be raised later. Lazy delay, lazy connection check. So that was also one of the important things that we discovered kind of late at the project. Okay, what we have to do at the project? If you have unknown thing, very, very specific, that core of your business, and you have to do this quickly, just create special team just to implement this particular thing. For instance, for rules engine, we have to discover how to do this, how user can define all these rules, what they can utilize. Do we have something out of the box on the market, or should we do something written by ourselves in Java? We have created a team with 4 persons. They were isolated from other team. The whole project was about 50 people. So yeah, this team was isolated. We took all of these Jira things, reporting things. Guys were focused just directly on the core thing, how to create this rules engine. And that was very useful. You know, if we still proceed with all of the things and try to figure out how to do this, we never reach such kind of results that this team actually bring in 1 month working prototype. That was really just one extra month, and it's production ready. Yeah. Data generator. For every big data project, you have your data generator. Data generator typically focus on 2 things. Run business scenarios and throughput, generating throughput. Do data generator. It's always useful. It's gonna help you, your team, development team. It's gonna help quality assurance team. It's gonna help DevOps team. It's gonna help everyone. So yeah, and one thing that what I told we didn't found yet, this is a stream manager. There is no out-of-the-box things how to manage your streams from some kind of friendly UI, you know, just starting jobs, stopping jobs, I don't know, define some basic things at the jobs. So we have to create our own. So yeah, it's still a gap on the market. If your company gonna create this, I'm gonna buy this. What else very important and that helps a lot on this project? Design, software design goes first, prior the development. That's kind of hard at every project. The developers typically do the coding and then cover with documentation. But just really try to do this backward. So first design, then coding. And if you have some weaker Confluence for your project, don't use, just ask your project manager or, I don't know, your owners of the business, buy these live diagrams. Lucidchart, Glyphy, whatever, Draw.io, no matter which one. But there is huge difference when you just copy pasting pictures of your diagram solution and when this is a live diagram, when everyone can actually update this. It's just a really big step forward for your documentation. Code review. For data lakes and data engineering, it's really rarely things when developers try to do a code review, but just do this. For every pipelines, you have created something, make a code review. That's kind of useful. It's a lot of things that we actually discovered under the code review. Okay. This is a ML AI conference, and I can't go without the ML AI for this project. So it was a plan where to use ML AI. And the place of this is these 3 things. At real-time streaming, at your primary storage, and of course, something hosted on OpenShift embedded in your application as UI representation, so forth. So that's the place of ML and UI at this project. It's not implemented yet, but that's going to be in the future phases. So in security analytics, what kind of use cases, how to apply your ML and AI? Of course, you have a lot of data in the big table, so why shouldn't we do this as a training data set? Or test data set, here you are. Just bring the data, messages from big table, and do your analysis. Train your AI and models. We have to implement something on a real stream, on the streaming application, on the streaming level. All the models could be applied, of course, in this rules engine. What kind of task we have to typically resolve in this business area? Anomaly detection. If something goes wrong that user didn't define implicitly, ML AI could help us to detect in automatic mode with some fuzzy behavior templates. We have identity database. All these hosts, IPs, names, DNS names, We still have to align this database of these identities and somehow merge them and match identities. So that's another application of the ML and the AI of this project. This rules engine, actually, there was no protection from the users of this system. So you can define a rule that could actually break the whole pipeline. Yes, that's true. The whole responsibility for the rules, that they are valid and they are okay, they fine, it was the whole responsibility for the end user. You know, that's kind of risky. So yeah, you still have an option to define parameters in the rule that your stream pipeline just gonna blown up. And some kind of statistical methods could help you define just this example of the high traffic rule. Instead of putting this static value like 1 megabyte or 1 million bytes, you can define a sliding average in the last 5 minutes or something like this. That's an application of this MLAI. Okay, as a conclusions, what I would like to mention here. If you have something unknown, something challenging in your project, do POC, do micro POCs everywhere. You don't have to know everything, just do POCs. Mutable objects, just don't do this. Don't include any mutable objects. In the very beginning of this project, stream analysis was mutable. When we switched to immutable, we got a huge performance increase. Try to limit the scope of what you do. Cut off all of the things that doesn't fit well or doesn't bring a big value at the project. Try to focus on the very core things. You don't have requirements clear for you? Create your own. Be the best friend with DevOps and quality assurance. Gerrit, I just got a pain from this. I have no idea why, but I don't like it. So I wouldn't recommend to use Gerrit. Git is our best friend for this one. And in the very beginning, if you are an architect, just sketch all of the things. Just make your own sketches in a very approximate thing and bring this to the big data architect or other architects from customer side. Sketch everything, then bring this to the dev team. That's the goal. What I said in the very beginning, common engineering practice. If you have big data or data analysis or something dedicated to the data project, bring all of this common engineering practice in this big data project. What kind of common engineering? Unit testing, CI/CD, infrastructure as a code, branching. It's really hard to find out in the data engineering all of the things. Just typical pipelines, developers, when they do their pipelines, they just, unit testing? Seriously? Why should I do this? No, that's not for me. They don't do this. They do manual deployment of the code. You like, just what? Stop. No, just don't do this. If you're gonna ask at such kind of projects, how fast you can roll out, set up a new environment, they would say, oh, that's gonna take 1 week or 2. There is no infrastructure as a code when they can, in 1 hour, bring the new environment. That's really painful. So just if you have such kind of project, bring all of the practices from the common development. That's what I like. That's what I recommend to do for everyone. Okay, thank you everyone. Hope you enjoyed this speech and you're gonna found something useful.
Спасибо большое. У нас есть пару вопросов из чат-бота. На экране первый.
Customer got a lot of discounts on this GCP. If you have a huge discount, about 80%, of course you're gonna pick this cloud provider. Come on, just be honest.
И следующий.
DevOps. DevOps was about 5-6 persons. 2 of them, 2 persons were at our side, and 3-4 persons was at customer side. So, yep.
Спасибо большое. Кто-то из зала хочет задать вопрос?
English, по-русски, украинско, будь-яка. Go ahead.
So, do you hear me?
Yep.
Oh,
Probably they don't hear you.
oh, okay, thanks. Stupid question. Why do we need to set up quickly environments like ML? What is the real use case?
What's the benefit of this?
Yeah, I need this environment in 1 hour. Why,
Uh-huh.
why do you need it?
You have some major feature implemented. You know, it could affect your other features. So yeah, you would like to test this isolated. It doesn't mean that you have utilized your dev environment or quality assurance or pre-prod environment. You really need to quickly make a copy of your prod or very similar to prod and test just there. So for the major features, yeah, I would recommend to do this on a separate environment. And then tear down when you have good testing of this feature. Yep.
And how you test and whole system?
How you test what?
Whole system.
All system
When you
on the
add
same
this-
environment with this feature.
Okay, thanks.
Yeah.
Еще есть вопросы? Да.
Yeah, first of all, thank you. And the question is, what did you end up using as a rules engine?
Oh, yeah. Nice thing. It was a Java written custom DSL. You have to define this in a JSON format. And we put UI as a generator of such kind of DSL, of this JSON. JSON has terms from Apache Beam framework. So it's defined as JSON. Your pipeline just filtering, aggregate something, join, union, and it's not like SQL, but it's closer to the paradigm of this Apache Beam framework. And user have the options to write these JSON files or use UI as a constructor of this JSON file. That was the option. Yeah.
Thanks a lot for the talk. Just one question: why choosing actually Apache Beam and Dataflow over Datapros and Apache Spark?
Auto-scaling. One of the most, Apache Beam is a more universal framework. If you write down something at the Spark with PySpark, JSpark, whatever, with any languages, you stick with Spark paradigm. Apache Beam, that's the next level of the batch and stream job definition. And you can actually run your Apache Beam defined jobs on top of the Spark. So yeah, and of course at the GCP, Apache Beam was out of the box on top of the Dataflow.
So like more abstraction.
Yeah.
Okay, thanks.
Thank you for the talk. I made maybe wrong conclusion that you replace a lot of custom implementations with the existing Apache products.
Yeah, try it.
Doesn't it put you at the mercy of the developers of said products? So if, for example, NiFi has a bug or Kafka has a bug, you have to like wait until they resolve the issue. Did you have problems with the increasingly difficult support of Apache products, which you rely upon?
The benefit of the open source project that you can actually fix it by yourself. You don't have to wait. It's one of the options. We didn't face it. Kafka it was in a very simple way. That's why we didn't actually experience any issues. With NiFi, interesting thing that we implemented our own processor. And Apache NiFi API is kind of simple to extend. Yeah, we have a Java team developers that just has written their own processor. And that's fine. It was not a big deal. Just 1 week of development.
So you didn't have a situation anyway in the course of the project
Mm-hmm.
where you couldn't do something because of a bug in one of the Apache products?
No.
You're very lucky.
Есть еще вопросы?
Yep.
вопросов нет. Спасибо большое.
Пожалуйста.